Thanks for coming today. I'm David Green. I'm an enterprise solutions architect, and today we're going to cover EBS snapshots, and specifically backing up EC2 instances with snapshots. So today we're going to basically talk about where blocks fits in for EBS block, what block service is, and snapshots and how they work. And we're going to dive in a little bit about encryption, sharing snapshots across accounts, across regions, how keys work, how billing works. Pretty much all you want to know about EBS snapshots, hopefully you'll get out of the session today. If not, we'll be hanging out in the back of the room, so please ask me questions. We'll take questions at the end, off stage. We also have Ari from the solutions building team at Amazon Web Services here to demo Ops Automator, which is an automated tool for managing snapshots and some other components and AWS services that we offer. And then throughout the session, I'm going to cover some common questions that we run into in production and common things I see from the field that customers ask. So AWS provides a complete building set of storage offerings. So in the core, we have Object Store with Amazon S3 and Glacier. We have file services through Amazon EFS, and also Block with EBS. We offer many ways to move data in and out of the Amazon cloud. And one of the interesting ones as it pertains to EBS and snapshots is Storage Gateway. So Storage Gateway has three flavors. There's file, disk, and tape. But with the disk offering, the volume offering, it exports an iSCSI block device for use on premises. And you can snapshot that block device, and it appears as an EBS snapshot they can use to turn up EC2 instances and have your data accessible on the cloud. So there's some interesting use cases we see. Some may be using it as disaster recovery. Some customers use it to burst on the cloud for compute reasons, but it makes it super easy to move data back and forth. And on the security and data management side, Amazon Macie looks at S3, and it's a really cool offering we offered a few months ago, so definitely check that out. And today we're going to talk about IAM and KMS a bit as it pertains to EBS. So we have two block offerings. One is EBS, which we're going to dive into, and we also have EC2 Instance Store. And I'm constantly asked, what's the difference between block? Why would I use EBS versus Instance Store? And there's a few main things. So Instance Store is local to the instance. So the hardware that's running your EC2 instance, these are physical disks inside that machine. And it's non-persistent data storage. It's ephemeral. So what that means is if you delete the instance, if you terminate the instance, or if it fails, the data associated to those disks is gone also. There's good use cases, though. We see customers use this as high IOPS volumes. We see it used for local caching. On the instance side, there's three flavors of disk. So there's NVMe-based SSDs that provide very high IOPS and throughput. There's SSD-backed volumes and also HDD-backed volumes. So based on your workload, you can choose the instance with those types. However, there's no snapshot support. And that may be fine for many. So Infor, for example, had to back up 2 petabytes or so a day of SQL Server data, and they're running the I2 instance type for those local disks. So what Infor did was they attached EBS volumes to the instance, ran their backups to EBS, and then from EBS, you create a snapshot that persists in S3. So there's still ways to leverage both in a hybrid mode. So let's look at EBS. EBS provides persistent block storage, and the EBS volumes are decoupled from the instances. So what that means is if you're terminated your instance or if the instance fails, your volume can still persist. Another interesting thing with this is you can change your instance type from maybe a smaller size to a larger size and retain all your data on EBS. So we see some customers using this, for example, rebalancing Cassandra clusters, where you need a ton of CPU to do the Cassandra rebalance. And when you're done, you just change your instance type to a smaller size, and you pay less, and then you're back in production. You can also modify your volume type. I'm going to talk about this a little bit later, but it's one of my favorite announcements that we made this year for EBS. We have two main families for EBS. So we have SSD-backed, and that's IO1 and GP2 are the volume types. IO1's really designed for the high IOPS and high consistency IOP performance. GP2 is a general purpose workhorse SSD volume, which really addresses almost all workloads we see out there. So I would definitely suggest starting with GP2, and you can always change if you need to. On the HDD-backed volumes, we have ST1 and SC1. These are great volumes for sequential workloads. So we see customers using this for backup targets, like the Infor case. We see customers use this for media streaming, for Cassandra commit logs, and other things that work really well with sequential block access. And you can choose between these types on ST1 and SC1 based on the performance you want and the cost. And the cost information is here as of it is currently, based out of the US East 1 region. So like I said, one of my favorite things is we have the ability to change volume types with a service we call Elastic Volume, or a solution we call Elastic Volumes. So you can increase volume size. And literally, when you increase the volume size, it happens nearly instantaneously. It's available. You can adjust performance. So if you have an IO1 volume type, you can change the number of IOPS you want for that volume as your needs change. And you can change the volume type. So if you're doing something like time series data collection, you need high IOPS. Once you're done, instead of copying the data to a different volume, you can simply change the underlying technology from, let's say, the IO1 to inexpensive SC1 or ST1 disk. And it's one of my favorites because you can do this in production without taking downtime. So there's no more late night, I have to do this thing on a weekend or holiday and have unhappy family because I'm working late night. It's just do this live in production and there's no negative impact on the app. EBS is block storage as a service. And the reason I call that out is we don't go ahead and attach a hard drive in the cloud to your instance. EBS is really comprised of a large distributed fleet that makes a single EBS volume. So this is important to call out because it allows us to do some interesting things, such as elastic volumes and the snapshot support that we're going into in this session. EBS is designed to deliver 5 nines of availability at a 0.1 to 0.2% annual failure rate, or AFR. So what this really means in production is if you have 1,000 volumes out there, you can plan on having 1 or 2 fail and not be recoverable. And that's why it's important to snapshot. We're going to do a quick, super high-level 101 of how to create snapshots. So in the console, click on Volumes, select your volume that you want to snapshot, and say Create Snapshot. Next window you get allows you to name the snapshot and have a description tag. And if you guys only leave with 2 things from the session, please leave with take snapshots, and please tag everything and have descriptions, because it makes life that much easier on the cloud. Once you hit the button to create snapshot, this is what you see. The snapshot creation process started, and this happens very quickly. From the command line, to view the console, to view the snapshot in the console, you go to the snapshots, and you see the new snapshot I just made. Something that I want to call out here too is it says the snapshot size is 80 gigabytes. That's because the volume I created was 80 gigabytes. We only back up data that's new in that volume. So although we show 80 gigs, you're not backing up a full 80 gigs, and I'll go into exactly how that works. But this is something that comes up. So just know we're only backing up unique blocks in the volume. Doing the same thing from the CLI, you just create snapshot. I'm specifying my volume ID. I'm naming a description. Because my volume was encrypted already when I created it, my snapshot is also encrypted by default. And to view, it's basically the same as the console and the command line. I'm viewing a snapshot. You see it's encrypted. I get my snapshot ID. And that's pretty much it. And something that comes up that I just wanted to clear, every EBS snapshot functions as a full point-in-time backup. So that means that you can take snapshots, let's say, every day. And although on the service side, we treat each snapshot as incremental, meaning we only back up unique blocks incrementally to the snapshot service, Each snapshot is completely standalone and able to function as a full point-in-time, full backup. So this may be different from how things are done on premises of doing, let's say, daily incrementals and a weekly full or whatever the schedule is. Every single snapshot is a full, essentially. And we do this to reduce costs. So customers are only billed for unique data per volume in the backup service. It's a full point in time of only modified blocks. The snapshots are stored in S3, which has 11 nines of durability. Snapshots are incremental. And what's interesting here, too, is there's no performance impact taking snapshots. So in some storage systems, you might have I/O on the disk associated with that snapshot. If you copy it off the file system or the hardware, there's no negative impact of taking snapshots on EBS. And when you delete a snapshot, only the data that's exclusive to that snapshot you delete is deleted forever. And EBS snapshots are crash consistent. So crash consistency and there's application consistency. So to show the difference, a crash consistency, basically think of it as if you unplug the server from the wall, from power, any data that was on that disk is in the snapshot. So for example, if you have application data that might be in memory and it wasn't flushed to disk, when you create the snapshot, we definitely won't see it because it's not on disk. So the easiest way I think of it is, like you're pulling the server plug from the wall. And crash consistency is fine for many cases. If you have some data that doesn't care about the application state, it's fine for many, many cases. And there's application consistency. And app consistency means that basically all application data is flushed to the disk when you take a snapshot. So for example, data that's in memory gets flushed out. New writes are either halted or paused until the snapshot completion finishes. And then once that's done, you can unfreeze the disk and start writing again. So for example, on Linux, you can do stuff like fsfreeze and sync the write data to disk. And what's really interesting with EBS snapshots is when you run the snapshot command either from the console or from the CLI or API, it finishes very, very fast. So it's definitely in seconds. I would try it just to see how quickly it returns. So when you hit the return key and it says snapshot creating, it's super fast. And what that means is for your application, you don't have to pause the application that long. You can just pause it when you need to, snap, and keep moving. A new feature we announced this week or last week is VSS support for Windows applications. So this has been a constant ask from Windows customers, and as we do with our product roadmap, we listen to feedback and we develop our features based on customer input. So one of the biggest requests from Windows customers is please support VSS. So this allows for VSS applications or supported applications such as SQL Server and Microsoft Exchange. And VSS manages the disk operations. So when you create the snapshot, it does exactly what we talked about. It basically pauses I/O and has a way that you can create consistent snapshots. And there's no more need to freeze the application or maybe stop the application when you take the snapshot. It just makes things that much better for Windows customers. VSS support is powered through SSM. And SSM allows you to run commands on your instances. So in this case, we're running the AWS EC2 create VSS snapshot. You select the instances that's commands executed against, and you create your description that's being tagged to the snapshot and your tags. So tags could have things such as business unit, cost center, all these things that help you identify what the snapshot is. And the VSS service is enabled on Windows AMI versions 2017, 11.21, and newer. If you're running an older version of Windows, you can still install the VSS agent through I have it on the website here. You can actually install it on existing AMIs. But now that we saw a little bit about how to create snapshots and how they work at a high level, how about automation? Like as you scale out, you probably don't want to be managing snapshots yourself. We have some resources online. We have some blog posts here of how to create application consistent snapshots and some community-based resources on GitHub, such as Elastic. So let's say you're out to do this yourself. You want to make an automated way to create snapshots. Here's some tools you can leverage for doing this. Some key ingredients, we'll use AWS Lambda. So Lambda is a serverless tool that allows you to run code in your build in milliseconds. Amazon EC2 run command. And again, tagging. So what we're doing is we're going to have a couple tags for the instance. We'll have a tag that says backup, and a tag that says how long you want to retain that backup. Lambda supports cron-like syntax, so you can say every day, or whatever frequency you select. So let's say every day we run a command for Lambda, and that command's going to look for any instance I have that have the tag that says backup. You can optionally run EC2 run to create a file system, so halt IO, flush out memory. Snapshot the volumes. And then finally, you're going to tag the snapshot with the expiration date that you have. So in this case, I'm saying 30 days. Another Lambda function, for example, could run every day. And what that's going to do is look for snapshots that say expire today, and then go ahead and delete those snapshots. So that way, maybe from a cost perspective, you can only keep what you need, and also it keeps things hopefully clean, so you don't have a ton of old stuff you don't need. And this may be fine for many, but we see customers that have a hard time scaling with this. So Ops Automator, which Ari's going to speak about here, Ops Automator allows you to run at scale. And what's really great about Ops Automator is you can start small with single instance, single volume. And we have customers using this with thousands, tens of thousands of instances, thousands of volumes, multi-account, multi-encryption keys. And what's really amazing is it controls things such as exponential backoff if you're being rate limited by the API. It lets you do things like retry logic. It has really great audit logging, so it logs well through Dynamo, and it tells you what's happening, what happened when, and it's really scalable. So for more information, I'd like to introduce Ari.
Well, good afternoon. My name is Ari Lebenstein. I'm a solution builder in the global accounts team. And what we do, we work with customers and we help them to implement solutions like this, like David described, solutions for backups, automating all kind of operational stuff. And again, we talk about large volume of instances, large volume, many services, and we want to automate things. And we see a lot of do-it-yourself projects, and we spend a lot of time helping the customers. Sometimes we build it for them. And we keep on repeating ourselves, error handling, logging, scaling out. And we thought, well, why don't we build a framework we see a lot of patterns. We're solving the same problems all over again. Why don't we build a framework that, allows you to implement these actions, very rapidly, just focusing on your automation logic. So that's a bit of a story behind Ops Automator. So what is this Ops Automator? It's a framework that allows you to very simply build actions that operate your daily operations. Like I said, we saw a lot of patterns, we implemented them, and we started with a very small implementation, just implementing a couple of actions to test if, to validate the framework. And again, we got feedback from customers and we keep expanding it. And what it allows you implement basically a Python class with a predefined interface, an execute method. You implement your logic in there, you more or less plug it into the framework, and we run it for you. You can specify when to run it at a specific moment in time or at a specific event, and I come back to that later. And again, people are asking me, don't we have that already in AWS? You have CloudTrail, CloudWatch. Yes, but again, it's everywhere. So what we did, we built a kind of layer on top of it, putting everything in one solution, managing it from one single configuration database. And again, the global team almost work exclusively with large customers. Think about very big customers. So we have to build something that, requirement number one is multi-account, multi-region. Again, no excuses, out of the box, that's what we support. And again, large scale. And David already mentioned it. And yeah, we build the first version. We start to work with the first customers. And hey, Ari, it's not working. Yeah, it's working here. Here it doesn't. So, you do a shared screen session. And snapshots, 25,000. Again, this is the kind of scale we operate in. And then you have to really start thinking differently. But again, that's something we handle in the framework. We have to think about, there's a lot of details about how much data can actually pass between Lambda functions in the payload. Our whole system is serverless. Not completely, but I'll come back to that later. But there's only 128K of data you can pass around between Lambda functions. And again, we have to process 10, 20,000 instance IDs. It won't fit. So we have to come with problems for that. Scaling. When you operate at this scale, you're hammering our backends pretty hard. And you get throttling. Again, you get throttled a lot. So we're handling that. Again, I ended up with a lot of loops in my code, retrying when throttled and things like that. Again, we built a layer on top of Boto. We use that, and depending on the service, we have backup strategies. Does it make sense to retry with throttling? Yeah, you can. Fatal errors? No, we don't. How long should we wait? And again, that's all in the framework. And also very important for large customers, centralized configuration. All the configuration, it's great to have a lot of Lambda functions hanging around, but what we do, we have metadata in a database. We have 2, 3 CloudWatch rules, and we control everything from there's one CloudWatch rule that triggers the actions. We go through the database, see what needs to happen, run the actions, and actually we suspend the CloudWatch rule. You don't want to burn CPU cycles. You don't want to burn. You don't want noise in your log files. Auditing. In the middle of the system, there's a big DynamoDB database. And actually, before you do anything, we created an entry in the database. And actually, the creation of that item triggers the action. You're done, we update it, and based on that update, we say, okay, what is the next step? So we're breaking down all the action in different steps. A select phase, an execution phase, and a completion phase. And again, that's where we saw a lot of issues with our customers. You start an action, and creating a snapshot is fast, but there's also long-running actions. You want to check, did it actually finish? What was, did it fail? Did it succeed? So what we're doing, you're also handling the completion checking. You simply implement a function saying, that says, okay, call this function, and when I'm returning yes or no, I'm completed. And we take care of calling that function. So we're not keeping your Lambda function hanging around for 5 minutes and hoping it will happen in 5 minutes. Because a Lambda function is great, I like them, but it's only 5 minutes. And some things just take longer. Selecting snapshots from a set of 35,000 snapshots. You probably not, well, sometimes you make it in 5 minutes, sometimes you don't. So we also found solutions for that. Basically what we do, by configuration in our V2, you can actually delegate that action to an ECS cluster. It takes the Lambda code, creates the context, and it runs as an ECS task. There's all kind of difficult things we had to solve. Well, auditing, we got a DynamoDB table. You see every step in processing the task. On top of that, with CloudTrust logging, things like that. Concurrency. Ever tried to implement a copy snapshot script? You can only do 5 at a time to a specific destination. Again, that's something, we had it in our copy snapshot task, but we moved it into the framework. And now literally we're having 2 lines of code in your Python class. We handle it for you. Give us a unique key and give us a number. So we put all this thing in the framework so you can really focus on the business logic. You execute method only, you implement it, it receives the selected resources based on metadata from your class. It receives a session for the cross-account role you gave us. You get a logger and you get all the additional parameters for the task. And you can focus on building your automation logic. Okay, we ship with, well, the first version. There's a URL. You see, we have a limited set of actions. We didn't want to spend, half a year building action that people might need. So we shipped a version with a limited set of actions. And it's not a coincidence. They're all focusing on EBS snapshots. There's big demand for that. And what we also allow, working on a developer's guide that allows you to write your specific custom actions. Okay, V1, like I said, small set of actions, purely based on the highest demand at that time. This, if you go to the link, that's a V1. We're about to update it in a couple of weeks to version 1.2. At the moment, we have a limit of 1,000 snapshots we can handle. And we fixed that in version 1.2. We'll be out in a couple of weeks. See me after the session if you want to give it a test run. V2, that's the big thing we're working on. We ship with this 20 plus, think about 25 plus actions. And all of the functions are built based on customer, working with big customers. Like, can you have an action that's, do this or that, and I can tell you, 1 or 2 days, that's whatever it costs to build such an action. Another thing we added is like, 20,000 snapshots. Okay, which one do I have to copy? And you want to do it fast. You have business requirements like, I immediately want to make a copy when a snapshot is created. So we saw customers like scanning 20,000 snapshots every minute. Okay. So what we did, we now allow you in V2 to trigger tasks based on events. So every time a snapshot is created, you can say, run that task. You don't have to scan. Or every time you start an EC2 instance, create a snapshot. It's much more efficient than scanning. And again, it's part of the framework. We improved scaling. Again, we added the possibility to run your Lambda code as an ECS task. By configuration, you say, well, it's probably going to take a bit longer. You specify the name of a cluster in your configuration. We start a task. It literally downloads the code from your Lambda function, and we run that code, and we have more than 5 minutes. So that really scales. We found solutions for, the under 28K limitation of Lambda, using S3 for that now. And again, it allows to do things for large accounts. We also solve things like, can you copy a snapshot across accounts? It's a logical thing they want. But it's not possible to copy a snapshot across account. You can share it, like in that account you can restore it. But again, we more or less build a kind of logical layer around it. So yes, we support now copying snapshot across accounts. Actually, you pull it from another account by configuration. Okay, for a high-level overview. Again, this is more complex than you see here. But it's more about how we're going to deploying this. Well, it's a simple, it's quite a big CloudFormation template. Think about 3,000 lines. You deploy it into your ops account, and it creates all the resources you need. It's asking for a couple of parameters, takes about 10-15 minutes, and it installs some Lambda functions, DynamoDB database, CloudWatch rules, everything is there. And what you do then, you can operate in your own account, but by creating cross-account roles for every action, you give Ops Automator access to the other accounts to perform the actions. We generate the CloudFormation templates for you. We narrowed the scope, security, very, very narrow, so it's safe. We only give you the permissions, or we only ask you for the permission you need, and we only give them to the role in which the Ops Automator is running. So we're not giving to the Ops Automator account, we give it to the specific role it is running into. Okay, to give you an idea about the actions we're going to support in V2. Again, I think in the magnitude of at least 25. Of course, EBS snapshot management. There's a huge demand for it. We can create, copy, delete, share reports like, how many snapshots do we have for that volume, when was the latest one, and we can tag them automatically. We're doing the same for AMIs. And we do EC2 instance management. We can start, stop, and terminate instances automatically based on tagging and timing. We can issue SSM run commands on EC2 instances. We find out, is this Windows, is it Linux? Based on the results, you can do follow-up actions. RDS snapshots, RDS instance management. We do the same for Redshift. We can automatically create and tear down CloudFormation stacks. And we do Dynamo capacity scheduling based on time. It gives you a bit of an idea of a list that is still growing. And again, this is all based, I could say, well, all of them are based on customer demand. This gives you some sample scenarios where you can implement with Ops Automator V2. What I want to do is do a quick demo. Well, actually, what I want to do is show you a end-to-end DR scenario. Because this takes about 20-25 minutes, it won't fit into the session. So I put it in a condensed video. And I'm going to run that video and I do the voiceover for that to show you all the steps that are required to do this. David, please unlock your system. Yep, that's it. Okay, what you see here is the scenario. It consists of 4 steps. The first one, automatically create the snapshots for tagged instances. The second step is we're going to automatically copy them to, from EUS to EU Central 1. The third step is cleaning up snapshots. If you have more than 4 for a specific volume, you clean them up. And the last step we're going to do in the demo is actually enabling to run it in multiple accounts. Okay, this is where we start with. We deploy Ops Automator as a stack into your Ops account. This is typically enterprise scenario. You got an Ops account and you got a resource account. So you deploy the stack. And here we go into the parameter screen of the stack. The task scheduler tag name is one of the most important parameters. This is the name of the tag which you use to tag your resources. You specify by the values of this tag which action you want to run. Okay, where are the actions? As part of the deployment of your stack, we dynamically create a bucket, and we also dynamically generate a couple of folders. And in the folder you see here configuration. We create the templates for you to set up all the actions. Well, every action we ship with the framework, and you see it's quite a list. This is a week old, and we already added a few more. These are dynamically generated templates. Why we do this dynamically? Because we want to narrow down the security. We want to make sure that we're addressing the right Lambda function, the right ARN, so you don't have to enter too much infrastructure parameters. Okay, first thing we're going to do is we're going to configure task number 1. So we're going to the create snapshot template, going to CloudFormation, and we create a stack. And a stack is a task. We give the stack the name of the task we want to create. It's create snapshot. Optional description. How often it's going to run? Well, once every hour, on the top of the hour. I want to run this in this region. You can specify multiple ones. I want to run it in this account. Support all 581 known time zones. You can disable it. You can collect cloud metrics. And this is very nice. It's something we're adding in V2. You can say, okay, run this task every hour, but also automatically when you start or stop an instance. Again, this is event-driven thing. Really, we build it to scale. Okay, what do you want to copy for that instance? You want to copy the root volume and the data volumes. Again, you can specify that with these parameters. You can share this with accounts. You can opt in to set the name of the snapshot. You can specify a prefix. You can specify a templated name. And in this template, in this name, you can specify things like, okay, what was the year, the date, the day, the hour, and also the source instance ID, the volume ID. You can put that in the name. Same for the subscription. And what you see at the bottom, you can also copy tags from the original instance ID. Again, I'm using a wildcard here. I want to copy all the tags from the original EC2 instance, from the volume, and I can add snapshot tags. And this is a very important one. Remember the first screen we were? Ops Automated task list. What we can do here, we can add additional tags to the created snapshots. And the tag is called Ops Automated task list. And we say, okay, on this snapshot, I want to execute the copy snapshot action and the delete snapshot action. And these are the next 2 tasks we're going to configure. And what you also can do is you can put tags on the instance on which you're creating snapshots from. So you can say, okay, snapshot adds, or you can also put a list of snapshots for that instance in the tag. So, task number 2, I want to create copies of that snapshot. I'm creating snapshot in EUS 1 for now, and I want to copy them to EU Central, to Frankfurt, automatically. So no scanning. Well, you can do scanning, but you know, large environment, it simply doesn't really work that well. So we're using the templates for the copy action. You create another stack. So we're leveraging the CloudFormation UI. Name of the task is copy snapshot. And as you see, I'm not specifying a task interval here. It's optional for this task. Go to the bottom. I'm going to specify, okay, I want to run this action when a snapshot is created. Or you can even specify, I want to run this action when another account says, okay, this snapshot is also available to my account. So you can trigger an action, like David is creating a snapshot in his account, he's sharing it with my account, and I can then automatically copy it into my account. Again, no scanning, just reacting to events. I want to copy it into to Frankfurt, EU1. I can filter on, which ones you want to copy, one owned by me or just the shared ones. Which tags do you want to copy from the original volume ID? Or from the original volume, yep. Again, what I'm doing here, I'm tagging the copy snapshot with an Ops automated task list, and I say, okay, delete snapshot. Eventually I want to delete it, so I put another tag on it, template description, and I can specify non-standard KMS keys when I want to share them with, encrypted snapshot with other accounts. Step number 2. Step number 3, I want to clean up my snapshots. Again, same procedure, template for the delete snapshot action, creating a stack, name of the action is delete snapshot. I want to run this every hour, quarter past the hour. Again, full cron specifications here, sport. And what I'm going to do here is specify 2 regions, because I have the original ones, and I have the copies in EU Central 1. I can delete based on retention days, like I want to keep the snapshot for, let's say, 31 days. Or you can say, delete all but the last X snapshots. And you can make the choice there. Now we're switching to EC2. Now I'm going to put a tag on each instance from which I want to take volumes I want to take snapshot from. So Ops automated task list. This is the name of the first task, create snapshot. It's easy as putting a tag on an instance. You see that the snapshot creation is started, EU West 1. While we wait this to complete, we switch to, after it's complete, we switch to EU Central 1, and you see that the copy of the snapshot instantly started, without scanning, without polling. We're triggering, hey, a snapshot has been created, now let's trigger task number 2. And you see, copied from, I'm using a template description there. And here again, I'm putting an Ops automated task list tag on it, saying I'll delete it after a while. Okay, what do we need to configure this, to run it in another account? Again, this is essential for large accounts. What do we need to do? You go back to the configuration bucket, but we now go into a different folder, roles, and we have templates with the same name. So for enabling cross-account for the create snapshot action, I take the template, and what I need to do there is I have to download it. Because why? I'm going now into the other account number 2, it doesn't have access to that bucket. So in account number 2, I create a stack from the template. And what the template does, it creates the cross-account role. And it's really, I only give access to do the actions I need to do to create a snapshot to the role in which the Ops Automator runs. I can give it any name. I can recommend to give it useful names, because you end up with a lot of these entries. Create snapshots remote. Like I said, it creates the role. And the thing I do now is I take the ARN of the role, switch back to my account, and there's a parameter called cross-account roles. You paste in the cross-account role ARN, and now step number 1 also runs in account number 2. And you have to repeat this step for also for 2 and 3. So this is what it takes to set up this account. If you have any questions, come to me after the session. If you're going to give the test run, version 1.2 or version 2, see me after the session, and thank you.
Thanks, Ari. So V2 is in preview. here's the email address that you can email to get added or learn more information about Ops Automator and V2. And again, I like it just because it gives you the power of starting small and also scaling large. And just executing actions based on event is pretty powerful. So how do snapshots actually work a little bit deeper under the covers? Every block that you write to an EBS volume is automatically replicated within the same availability zone. So EBS volumes are tied to an AZ. However, snapshots go to the snapshot service, which writes to S3, and S3 is a region-wide service, again with 11 nines of durability with S3. So within the snapshot service, let's say I create a new volume. Here's my brand new, let's say it's a 1 terabyte brand new EBS volume. I create a snapshot. It's an empty snapshot. So although in the earlier slide it showed that, it shows the 1 terabyte size in the console, we're not backing up any data, which means you're not billed for any data that's backed up. So let's now write data. I'm going to simplify this a little bit. I'm going to write 3 blocks to my volume and take a snapshot. Because these are unique blocks, only those blocks are written to the snapshot number 1. Now I'm going to delete blocks 1 and 2 from my EBS volume and take a second snapshot. And add more data and take a snapshot. We only back up new data. So block number 3 already exists within the snapshot service for that volume. So we're not going to back it up again. Instead, we're going to reference that in snapshot 2 and only back up new data to snapshot 2, in this case, 4, 5, and 6. Now I'm going to delete snapshot 1. When you delete, only data exclusive to that snapshot is deleted. So in this case, only data with blocks 1 and 2 is in that snapshot. However, 3 exists in both snapshots. So what we do, we associate block 3 with that snapshot, and then that snapshot is now deleted, the old snapshot. It's important to call out that when you delete a snapshot, it's deleted, like it's gone. There's no undo, delete snapshot. And just to further the point a little bit, I'm going to delete block 3 from my live volume, write some more data, take a snapshot. Again, only unique new data is copied over, in this case 7, 8, 9. And that's how the snapshot service works under the hood in a per volume basis. Well, how about encryption? When enabled, encryption is encompassing data in flight, so data written to EBS from your instance to the EBS volume, data at rest within the volume, and data stored in snapshots. Encryption is super easy. So it's literally a checkbox in the GUI. There's no performance impact of encrypting. There's no cost addition of using encryption in snapshots or anything like that. So it's just really easy to do. Volumes that are created from encrypted snapshots are also encrypted. And when you copy an unencrypted snapshot that you own, you can encrypt it using a key that you choose. And when you copy an encrypted snapshot that you own, you can re-encrypt with a different key. So for example, if you're using a default key for EBS and you want to use a different KMS key, you can do so by copying. So best practices for snapshot encryption. By default, we have the AWS EBS key, and that's in everybody's account. This is a unique key per account as well. However, we suggest creating your own KMS key to be used with EBS. To do so, you create the key. I'm calling it EBS master, and I'm tying a description of master EBS encryption key. And this allows you to do some fun things, like define key rotation policies, and more importantly, see CloudTrail access to that key and who actually has control to access that key. So now we're back here. For master key, I now have my EBS master key that I created instead of using the default key. Another trick in this window I like to do, you can change the size where it says volume. I have 500 gigabytes. If this is a GP2, this is ST1, it shows you how much throughput you have. On GP2, it shows you information as well. So it's really nice to see, if you want to see how fast it is, your baseline right there, you can just change the numbers and kind of determine your throughput of the volume in that window. Another new feature is with run instances command, you can now run with custom CMKs. So in the GUI, when you go to launch an instance, and you attach an EBS instance, it used to be a checkbox of encrypted or not encrypted, just like a yes/no button. And now you can actually specify which key you use in the console, or also when you launch from the run instances command. So that's nice to be able to specify the actual key of the volume you create. With snapshot encryption, we use a process called envelope encryption with KMS. So envelope encryption is a hierarchy of encryption. So the master key is created and stored in our key management system, KMS, and the key never leaves KMS. It allows you to encrypt one data key per volume, and every volume has its own data key that's envelope encrypted by the master key. This is stored in volume metadata. So when you want to mount a volume to an EBS instance and use it, the KMS service is called, the decrypted key from metadata, and then the decrypted key is stored in the memory of the instance. So now you're able to access that encrypted volume. And what's beneficial here as well is you limit your exposure risk. So although you have one master key, you have all these keys associated per volume, so your blast radius is a single volume. And also, all the data I/O stays locally between the instance and the volume. So you're not sending blocks of data through the KMS service to write data to your volume. It all stays within your instance and the volume. So what are some things you can do with EBS snapshots? Like I mentioned, EBS is tied per availability zone. So you can have an EBS snapshot go to AMI. AMI is an Amazon machine image that allows you, it's essentially a golden image. So you can launch many instances from the image. You can also copy snapshots between availability zones. So you have your EBS volume, create a snapshot, create a new volume in the other availability zone, and now you're multi-AZ with the same volume. In the same way, you can also copy the snapshot between regions, like Ari showed. So with copying a snapshot, when you copy an unencrypted snapshot, you can encrypt it. Then you can use a different CMK, like I mentioned previously. And when you copy an encrypted snapshot, you must have a master key. If you want to have your own custom key, have a master key per region you're copying into. Otherwise, you can use a default AWS EBS key. In this case, I made one called EBS Master Seoul because I'm copying from US West into Seoul. Now how about cross-account encrypted EBS snapshot copying? Cross-account EBS encrypted snapshot copying is really used for the purpose of copying. So for example, if I share to Ari an encrypted snapshot, he gets it, he cannot create a volume from it. So what he does is create a copy of that snapshot in his account, then he owns that snapshot, and then create snapshots from there. That's why Ops Automator is helpful, because you can do this automatically as soon as you get that shared with you. So it's 4 super easy steps. First, you share access to the custom key. Then you share the encrypted snapshot with the target account. And then from the target account, you find that snapshot, you make a copy of it. And then step 4 is really optional. You can create a volume. So what this looks like, I input the account ID of my target account. Inside the snapshots, I navigate to my snapshot, modify permissions, and now I share that snapshot with that target account ID. So it's really, it's a couple steps. It's super easy from the GUI. Now I'm in a target account. I see what's shared with me under private snapshots. It's easy to search. And here's a snapshot that I shared from my source account. I'm going to copy that snapshot so I can use it in my account. And now it shows up under owned by me. So that's my snapshot. And you have control to create volumes from it. You can delete it and all this stuff. So creating a volume from a snapshot, some best practices if you need this. By default, so snapshots are in S3. So when you create a volume from a snapshot, that data is loaded from S3 to your volume. And it's a lazy load off S3. And there's some ways to speed this up if you need to. So the way we suggest is to run FIO. FIO allows you to do a random read across the volume, which helps to speed up the process that EBS is hydrated from S3. So we're suggesting a block size of 128K and a random read. And what you want to monitor is the CloudWatch metric of volume total read time over volume read ops. And you kind of see where the latency drops. You see that's basically where it's hydrated. So you can basically stop the FIO command once you hit that point. You may not even need this. We see cases that it's perfectly fine restoring for volume from a snapshot, but we do see cases where this helps. Well, how about cost? Everything matters with cost. As of today, snapshot pricing, or as of this point in time, snapshot pricing is 5 cents per gig per month. And again, we only bill for unique data per volume in a snapshot service. And how about monitoring cost? So again, two things, snapshot and tag. Custom tags let you use detailed billing reports to view costs associated with that tag. So EBS supports custom tags for ID and for management. And with cost allocation, it's really easy to break down these costs. So inside the console, you can add tags. Use API call to add tags, or also in the command line, that's what it looks like to add a tag to a snapshot. It's important that you activate that tag inside the billing dashboard under cost allocation tags. Because you can have tons of tags, but we're only doing processing on costs based on tags that you tell us to. And so you go to cost allocation, and it may take 24 hours or so for that tag to be represented inside billing. EBS volume support tag on create, and the command line below creates an encrypted 100 gig volume with the tags there, bees1, and an environment values prod. So some ideas, this is, the command line showing as soon as you create that volume, this is what it looks like. So you see it's there immediately. And some ideas of what tags you can use. So I don't think you can ever over-tag stuff in a way that is helpful for you to know what's what. So we see customers using maybe the environment, the cost center, the application name, anything that helps you identify what you're doing. In cost allocation, you actually see a visualization of cost. So you can break down and say, show me anything that's dev and how much space it's using or how much cost it's using. So maybe you don't want to pay a ton for dev. Maybe you have tons of snapshots that were there before. You can delete dev and really focus on prod. We also put this data into the detailed billing report through, you can download and process your CSV. And there's third-party tools you can also use to help process data from the detailed billing report to make it easily digestible. So please snapshot early and regularly for best practices. And there's no need to stack snapshots. So you don't have to have multiple snapshots running before they even complete. Quiesce the application data if you need to for application consistency. And leverage automation tools where it makes sense. So again, you can start small with automation, and it just works with you as you continue to scale. So it's really easy to deploy. And please tag everything. At reInvent for storage training, we have some hands-on labs at the Venetian. We have the Meet the Storage experts. We have a lot of things here. We have self-paced learning on training online. And for enterprise storage engineers, you can work towards accreditation and also how to architect highly available storage systems. Other EBS sessions that are worth checking out are here. The ones I call out are deep dive on EBS. We have several of these, and all these are going to be on YouTube within a few days as well, so all the content will be there. And thank you for coming, guys. And please, if you can, fill out your survey. It really helps us tailor content for future sessions. And thanks for coming to reInvent.